All right, as a revision sort of three-dimensional trigonometry and Pythagoras, I'm going to work a few examples. There's an earlier unit that we covered in year 10 that covers trigonometry, and so we've already seen a bit of the three-dimensional trigonometry, which also involves Pythagoras. So hopefully this is mostly revision. But let's take a look at example 1. We're asked, given this cuboid, to calculate angles ABE, ECA, and EMH. I find that the easiest thing to do here is to draw out individual triangles representing each situation. So let's start with ABE. We're looking at the angle that's connected by the points A, B, and E. So I'm going to draw out that specific right triangle and actually label it A, B, and E. And the angle that we're looking for is the middle value, the angle formed by A, B, and E. I'll call that theta. And let's see, we know that the distance A to B is 22.5. And then let's see, the height here is matching this value here, 40. So all of these heights of the entire cuboid are each 40. And we can use that information to find our angle. Let's see, we're working with trigonometry and we want to use the inverse of a function to find the angle. Since we have the opposite in the adjacent value, we use tangent, or tangent is equal to the opposite over the adjacent. I know a lot of you use this triangle when you're solving, but we also know when we're finding the angle, we use the inverse operation and then divide the opposite by the adjacent value. So we would take the inverse tangent of 40 divided by 22.5. So let's see. So in the calculator, 40 divided by 22.5, inverse tangent, we come up with 60.64 degrees. Usually just don't round it off when you're actually working with this in the calculator. Avoid rounding as much as you can until the very end. I've seen situations in which students lose marks just because, or their answer is quite different at the very end just because they've rounded off a bit too early. So make sure later on, if we need to use this value for any reason, that we don't round off too soon. Okay, the next angle that we're asked to calculate, so there's our answer for the first bit. The next angle we're asked to calculate is ECA. ECA. So we are looking at E, C, and A, those pieces together. Let me draw out that triangle. We have a right angle at A because EA and AC will form a right angle as we go across. And then we have C over here. So we have a right angle here, and we're looking for the angle ECA. So this guy here. All right, let's look at pieces of information that we do know about this angle. This triangle. Let's see, ECA. We know the height of the triangle, or of the cuboid, is 40. So the height of this triangle as well will be 40. And then we're missing this piece of information, and we're also missing this piece of information. The quickest thing that we could calculate is the value of AC, the length of that piece of the triangle. We'll call it X, because if you look at this triangle ABC, let me draw that out. Let's see, A, B, and C, that's a right angle here. Angle B is formed by a right angle. This is 22.5 and this is 30. So we can easily find the hypotenuse of this triangle AC, which will match this value here. So whatever I come up with here using Pythagoras, since I have all or both sides of that right triangle, we can find the hypotenuse, which will match here. So whatever I come up with, I'll bring over here as well. So using Pythagoras, I'm looking for the hypotenuse. I take the square root of the two legs squared and added together. So let's see if I can do this on this calculator. 30 to the power of 2, or 30 squared, plus and then take the square root. Sorry, it's going to take me a while. Okay. So I get 37.5 as a square root there. So 37.5 ends up being this value here. All right. So now we have enough information over here to find that missing angle ECA. So I would take the inverse tangent, much like what we did earlier, of the opposite divided by the adjacent. So 40 divide 37.5, inverse tangent, and you come up with your angle. 48.81 is what I'm coming up with degrees. Okay, so there's angle 2, ECA, check, done. Last thing we're looking for is EMH. Notice that in the cuboid, we're told that M is the midpoint of FG. So when we connect these two pieces together, we're actually forming an isosceles triangle in which ME and MH are equal in value. And then we can kind of split that triangle into two pieces to form a right angle. So we're looking for that angle EMH, and I'll show you exactly what we need to do to calculate that. Looking at our triangle EMH, like I said, I was going to divide it in two, and I have. We formed two right angle triangles. And now let's just look individually at one of those triangles. I guess this is E and this is M and this is some whatever value. Just pull it over from here. Let's say that EH, we know totally from E to H would be the same distance as the bottom across, which was 30. So half of that would be 15. From here to here would be 15. And then let's see, we also need the height of that piece, which would be the same as the height of like EF, which is 22.5. And so we're really looking for this angle here, which would match this angle right here, which we can double to then find our total answer for EMH, okay? So again, we'll use inverse tangent because we have opposite and adjacent. Inverse tangent of 15 over 22.5 to find our answer. And let's see what that gives us. 15 divided 22.5. Then inverse tangent. So 33.69. But remember, we need two of those, so I'm going to take 33.69 times 2, just times by 2 in your calculator, and you should come up with 67.38 degrees. And that would be the answer for the last angle that you're looking for.